Now you'll see some of the special components of the DPC pump. In this case, the electromagnetic advance switch, as you can see, is located in place of the piston plug. To perform the disassembly, you must first disconnect the ground cable. Next, the protective cap. Then the fast idle lever and the rubber protector. Detach the cable from the bracket. Loosen and remove the solenoid nut. Remove the cable from the connection terminal and take off the clip holding the cable to the bracket. The final step in this case is to remove the electromagnetic advance. Now move on to the pneumatic corrector and start the disassembly. Loosen and remove the locking nut, protector, adjustment sleeve, and spring. Now loosen and remove the 3 screws from the cover, which will allow you to remove it. Remove the membrane and finally loosen and remove the body. The connection cap will also come out. Now observe the mesh filter in the corrector's housing. This should be replaced with a new one. This is the corrector's piston, which is housed in the central bore. The assembly of the pump with the corrector is practically the same as the normal ones, except you must also perform the following operations. First, determine the excess spring washer. To do this, take the measurement shown on the screen, from the rear end of the pump body to the spring seat bushing. You must also take this other measurement on the head. Place the depth gauge on the guide plate. Slide the ruler to the flat face of the head. Assemble the corrector, place the connecting sleeve and the body. At this point, you must tighten the body and the light load and delay valves as follows. There are 2 possibilities. Pumps with the corrector on the left and pumps with the corrector on the right, when viewed from the coupling in both cases. For the case with the corrector on the left, the tightening order is as follows. Boost corrector, overload valve. Advance valve screw and light load advance screw. For the case with the corrector on the right, boost corrector, overload valve, light load advance screw, and advance valve screw. Continue the assembly by inserting the corrector's plunger with its smaller diameter facing inward. Place the membranes. Fit the cover. And secure it with the 3 screws. Attention. To ensure proper centering, the 3 screws should be tightened alternately before applying the final torque kick. Place the spring, adjustment sleeve, protector, and locking nut. As a preliminary adjustment, you should turn the adjustment sleeve only 3 turns. With this, the pump is fully assembled and ready for adjustments and tests. The test data for the DPC pump have been obtained on a cartridge test bench under specific conditions, as specified by the test data for each pump. Obviously, the test bench must comply with all the requirements set by the ISO standard. Begin the calibration by setting up the test bench according to the type of pump to be tested. Prepare the pump as well. Place the adapter on the shaft and mount it on the bench. Now observe the connections and measuring instruments. Internal pressure and overflow measurement. Advanced tester. transfer pressure, solenoid feed, and high pressure outlet. Next, following the test data order, you will carry out the preliminary positioning of some components. Set the light load valve lever at 90 degrees to the pump axis. Place the advanced selector in the correct position, in this case degrees. The oil should be between 38 and 42 degrees Celsius. Place the 3 mm diameter rod in the idle and stop lever. Adjust the feed pressure to the value indicated in the test data and begin the test now. Fuel should come out through the injectors and there shouldn't be any bubbles in the surplus. This condition is necessary for the pump to stabilize. At 1,250 revolutions, you should adjust through the valve to the corresponding value. At 1,250 revolutions, you must adjust it through the valve to the corresponding value. To make this adjustment, stop the bench, place the throttle lever at its minimum stop. Remove the rod from the idle stop lever. Remove the valve cap. Place tool 1804-444 and tighten the screw fully. Adjust. Set the bench revolutions to those indicated in the data and loosen the valve until the excess increases by the determined value. A simultaneous drop in transfer pressure is also observed. Now set the advanced tester to 0 by first moving the light load lever towards the high pressure outlets. This time, you will check the solenoid closure. To do this, disconnect the cable terminal. The flow rate should not exceed 0.4 cubic centimeters. Stop the bench for at least 10 seconds and wait for the internal pressure to be below 0.1 bar. Reconnect the solenoid terminal. When connecting the vacuum gauge, the depression should be as indicated in the data within a specified time. This test shows us if the advance curve is within tolerance. You can also see if the transfer pressure meets the same criteria. Verify that the test data requirements are met. The data specifies a flow rate and tolerances. In this example, the flow rate should be 33.7 plus or minus 0.5 cubic millimeters. As you can see, the flow rate is below the minimum, so it must be readjusted. Take the flow correction table and first position yourself at the piston diameter of 6.5 millimeters. In this case, the flow increase decided is 2 cubic millimeters, so the angular correction to give to the screw is 23 degrees. Take tool 18,423. Remove the inspection cap, turn the pump shaft until the adjustment screw aligns with the cam ring hole. Insert tool 180.4423 into the screw. Set the index to 0 and turn the tool key 23 degrees clockwise. Replace the inspection cap. Prime the pump as at the beginning and check the result on the screen. Note that the dispersion between cylinders does not exceed what is established in the data. Also note that the flow rate is within the established tolerances. Place the specified thickness from the test data between the throttle lever and its minimum stop. If the flow rate is not within the allowed range, adjust it using the anti-stall screw. Position the valve lever towards the high-pressure outlets. Insert the thickness specified between the values in the data, between the throttle lever and its minimum stop. The flow rate must also be within the values indicated in the data. If not, change the thickness for a larger or smaller one as needed. Remember the thickness limits. Once the flow is achieved, connect the throttle lever and light load through the linkage and adjust it to achieve the advanced values indicated in the test data. On occasion, place a thickness 1 mm less than the previous test and check that the advance is within the limits established in the test data. A second check of the light load is achieved by setting the throttle lever to minimum and observing that the results are as indicated. Begin the regulator tests. With the throttle lever at maximum, note the flow delivered by the pump. Now adjust the regulator by setting the bench speed to the indicated value. Move the throttle lever until you achieve the flow reflected in the test data. Next, lock the maximum speed screw and verify the flow again. Now check the total cutoff of the regulator. Now you should observe if the regulator recovers when the revolutions drop to those established in the test data. Stop the bench and wait until the internal pressure is below 0.1 bar. In this condition, observe that the start delay is within tolerance. This test indicates if the excess flow for starting is correct. Now verify the cancellation of delay and overload. Taking into account what is indicated in the test data, adjust the minimum speed or idle through the corresponding screw. Let's consider the case where the pump includes a pneumatic corrector. To To perform the adjustments and tests, in this case, you will need a pressure regulator connected to the air pressure network, which will branch a line to the pump's corrector and another to a pressure gauge. The tests are included in the data among the usual ones, and their sequence is as follows. Start by adjusting the corrector through the screw, in this case without pressure. The maximum flow adjustment will be done through the strip with the corrector pressure at maximum. You will also perform a check at an intermediate speed point, also at maximum pressure. Now finally, adjust the corrector screw without air pressure. This other test is done with slightly lower than maximum pressure. Some pumps include a mechanical over-advanced system to check that it works properly. Set the bench speed to the one indicated in the test data. Set the throttle lever to minimum and the fast idle lever to the fast idle position. Adjust this through the connecting rod. Place the levers back in their normal position and check that the advance returns to its initial position. For pumps with hydraulic over-advance, set the test bench speed to 450 revolutions per minute. Place the valve lever in a horizontal position towards the head. This way the advance is cancelled. Set the advance indicator to 0. Place a 4 mm spacer between the fast idle lever and its minimum stop. Gradually move the ball joint lever through the connecting rod until you achieve the advance indicated in the test data. To verify the adjustment, remove the 4 mm spacer and the advance should be 0. Checks to be performed to verify its operation. Contactor control. Supply the contactor poles with 12 volts. Connector warning lamp to the fast idle lever. It doesn't light up when at rest. Push the lever to the fast idle position. It should light up. Now check the electromagnetic push button. To do this, connect the positive terminal to the solenoid terminal and the negative to the contactor. Do not confuse this phase, as reversing the polarity will destroy the electromagnetic push button. The rod should extend, and this measurement will depend on the type of push button. See the specific information about this. Finally, check the resistance. This should be 8 plus or minus 0.5 ohms with a fast idle lever at rest and the engine hot. Push the fast idle lever to the throttle position. The resistance in this case should be 4 plus or minus 0.4 ohms. You can now remove the pump and prepare for the adjustment. Place the pump on the appropriate stand and begin connecting it. Attach the tool 1804003 for pressure to all 4 outlets of the pump and select the pressure control valve. Connect the tool to the injector tester or to a sufficient pressure source. Screw the pressurized air supply tube into the pump's intake. Place the throttle lever in the maximum position. Insert tool 18,492 and counterweight 18,498 onto the shaft and position the weight as indicated in the test data. Move to the regulator cap and remove the plug from the adjustment fitting. Insert the probe into the fitting and place the comparator stand. Secure it. Place a centesimal comparator on the stand and ensure contact with the probe. Zero the comparator. Pressurize the pump as indicated in the relevant information. And observe the cancellation of the automatic delay through the advanced tester. Operate the injector tester lever, which will increase the pressure reaching the pump. Now move the counterweight until you feel the rollers hit the cam ring. When this collision occurs, the angle should be approximately 30 degrees. From this moment, maintain the pressure and move the counterweight again until the collision occurs. At that moment, read the value marked by the comparator and repeat the operation several times. The readings should be the same. Once the calibration value is secured, record it on the calibration plate, which is blue for service, and place it in its slot. The pump is now complete. Now you must ensure there are no leaks through the seals. All tests and adjustments made to the pump are correct. However, poor synchronization in the engine can result in its malfunction. Therefore, this is also a very important phase, and you should carefully follow the next process. The check is carried out taking into account this value and the TDC indication, which means top dead center. Place the comparator. Set it to 0. Next, move the engine until you read on the comparator the value indicated on the calibration cover. With the pump in this position, insert the rod into the engine's calibration reference hole. If it matches perfectly, it means the calibration is correct. In this case, you must first position the engine, which means inserting the rod into the flywheel hole. Push the sensor until it hits the pump guide. In this position, set the comparator to 0, release the sensor, and move the pump until you reach the value indicated on the plate. Lock the pump's fastening screws and verify the calibration again. With this, you can consider the injection pump repair finished. Proceed to check the vehicle to ensure its good performance.